to introduce friction and slowness in the operation. So while this is coming up,
do you want to stand here? Stand here.
Okay.
While this is opening, you can start talking while.
So I don't want to seem like I'm lurking in your direction. So, okay, we're going here.
Yep, and there we go.
All right, thank you. So, resource utilization goals. Tim asked me last year if I would lead this, and we announced that and called for volunteers to work on this. And of course, when he asked me, I was right in the middle of writing my survey proposal. And immediately after that, New Horizons flew by MU-69. So my progress has been modest as a result. But we've had our kickoff discussion. And basically this comes from the flow down of the previous goals document, which had an ISRU component in the human exploration goals. And as I understand it, the thought was that this really should be a standalone goal, not linked necessarily to human exploration. And so this was the starting point that I took from the goals document. And in my first approach was to expand that to include a wider variety of goals and objectives and discussions. And so this is a group that of the willing that has come together, and this is certainly not an exclusive group. If you'd like to get involved, please email me, and we'd like to hear from you. What we're going to do is essentially have a draft available in a few weeks and edit online, and everyone is welcome to join. What is nice is that we have a good representation of science folks and commercial folks. Because I think one of the issues is that there's considerable interest in the small bodies science from the commercial end and how that could help them move forward resource utilization. So these are the next two slides are topics that we went over. And what I would like to do is open it up for discussion, and I will discuss these things as we go. But I think one of the concerns that my group had was that resource utilization might be viewed as not scientific enough. And really, from my point of view, science enables resource utilization, but also you can extract a lot of great science while doing this. It forces you to consider what's going on the surfaces, the mineralogy, the entire package of what a small body is. So I think that not only is enabling for the exercise is in resource utilization is enabling for the science. And I don't want to steamroller on and not have any comments, so please interrupt me. Paul.
So one of the first things I would say is I agree there's science and resource utilization, and those are linked. But in terms of what's needed to enable resource utilization too, it's not just science. One of the things we thought about when we were dealing with the ARM mission was it's knowledge. So it's science writ large, yes, but there's also engineering and technology that needs to go into that. So in your first statement, that should also be a consideration, I feel.
So what science and knowledge?
Or for engineering technology. You can get very specific if you want, but that's the thing that people will need to be doing. And then what science can be extracted while doing resource utilization that's appropriate.
Yeah. No, I think that's a good point.
And I'm not sure that the second question is appropriate, what science can be extracted, because I think it's more that if we define what is needed for resource utilization, whether you call it science or just knowing what's out there, whether you call that science or just knowledge, I think it will become clear when we read the goals that we have for different things, there are overlapping themes.
Oh, yeah.
And so I don't think that it needs to be explicit within my personal opinion is that it doesn't need to be explicit within this section. I think that it will become clear.
That you don't need science goals within the resource utilization or science to be extracted? Okay, I'm trying to make sure I understand.
I don't think that you need to say that.
Okay.
That you need to define that, because I think that there will be things that it will be clear that doing these things for resource utilization will help these science goals.
Yeah.
We can make that link at a different place.
Okay.
But you can also point back to that chapter, right?
Yeah.
I guess that's what I was saying, is that you can point back. There's always going to be overlaps between the goals chapters, assuming these are chapters within the new version, and you can point back to, hey, this is for science, this is for the technology section, this is for...
Yeah, and links to human exploration.
Mike Evans Johnson. On your goals, would you like your goal page?
This was the previous goals document.
4 or 5. That is a huge process. The process of just developing a stimulant itself is a hugely scientific process. So I might separate that out from developing stimulant to the technology process of using the stimulant to demonstrate some type of utilization.
Okay, I'm familiar with developing stimulants, so I will certainly do that.
That just the whole process of developing stimulants for each of those different bodies is itself very difficult.
Sure.
And if I was breaking this down, I would be even more fundamental about survey and finding the object there. Captured in that word identify. But I think we're so far behind, in my opinion, we're so far behind where we really should be in terms of survey and population. To me, we're happy to do it. But the goal of the future is low delta B population.
Yes.
And anyway, I don't feel like I captured here.
Okay, well, that's what I was trying to do with the sub-bullet, identify search strategies to maximize discovery and characterization of resource rich.
But I would even say this is a whole separate reason to do we're trying to motivate pull up surveys. And I just think that finding them is this huge first step.
Yes, I can't agree more.
Like the St. Louis Arch gateway to the west. You have to find them.
So to summarize your point, we are well behind where we need to be, not just in planetary defense, but also in assessing the resources of nearer space.
Or just, maybe a statement, the first step for ISRU is to find the object that we can go to.
Okay.
And then that's its own impetus towards why we should be doing it.
So we do have Rob Jedicke on this committee, and he is a huge resource in the details and the insight of search programs.
Anyway, bottom line is I'm just trying to make sure that all the different corners that benefit from survey are making their statements, whether it's in-space resource utilization, destinations for human space, or fundamental science, and everything.
One thing that we're quite aware of is that the search strategies that you want to, and search objectives that you want to have for resource utilization are fundamentally different than planetary defense. That you're going to try to find things that have low relative velocities, that have long somatic periods, and that are probably too small to be a serious threat.
So that's a question for Paul Jonas. Is it a different survey strategy to find low delta V objects versus potentially hazardous?
It's basically the same strategy.
Okay.
You simply don't want their nest with the slow delta V ones. I think it's the same survey.
Okay.
So I think everyone wins. I think, thorough pull-up surveys, win-win-win for every dimension, and that's a concern.
Sir.
Yeah, I don't want to I guess here I go. I
Go ahead.
know that I don't know that I necessarily agree exactly because, right, the survey that's being defined now is to get down to 140 meters.
Yes.
And
This is, for the online audience, this is Andy Rifkin from APL.
Thank you. And it may or may not be the case that, that an object at 140 meters will be found that, that will be economically useful. But then once that survey is completed, the next step from a planetary hazard point of view is not going to be going to smaller objects. It's going to be trying to figure out long periods or comets or something if you actually want to reduce the risk. And that is a different survey versus looking for small things with low delta V. So there will be either look, we're doing this search for planetary defense, but it's kind of not the biggest planetary defense use. And also the resource folks are far more interested in the much smaller ones. Some of them are. Yes, well.
If I could just, I'm going to take the chair's prerogative and just step in for a second. Remember that what we're trying to do here is set out the goals in each area, and we don't need to decide here whether it's the same project that achieves a goal in planetary defense and a goal in resources or a goal in science. In part, I see the goals document as being a way that people can look and see what is it that is needed here or here or here, and can I help them? Can I help them?
Rick Menzel.
So just to converge with my friend Dr. Rifkin, the survey that is looking for hazardous objects doesn't throw out the small guys that it finds.
Correct.
So they are there, and it is a large funnel. You funnel your way down, but this is the next step, and you're not throwing out the little guys. So
well, yeah, absolutely, we're not throwing out the little guys, but the concern is that if you're interested in finding the little guys that have a synodic period that will drop them to low delta V nearer space in 5 years, so you can do mission planning, that might be a different requirement.
That was my question.
Yeah.
Fair point.
Yeah. The other thing that certainly I've noticed from dealing with people in the commercial end of resource utilization is that quite often they are not that cognizant of what the resources and the nature of the mineralogy of those near-Earth asteroids. And one of the things that we should talk about is what measurements and analysis are required to identify a resource-rich NEO and what constitutes an ore. Because an ore is not a geologic concept, it's an economic one. And many people, even in the resource industry, don't actually understand that in a fundamental way. So I think it's this community that has the scientific expertise that can really enable that kind of work. Yeah, Andy Rifkin.
Yeah, I don't know if this is in your number 3 or your number 5 kind of folded in, right? But one of the questions we get a lot, right, is, well, okay, you told me what the surface is, but how do I know that you dig 6 feet down and that's what the interior is? So being able to, I think one key issue for this is, right, to what extent does the surface, can you tell what's inside from the surface?
Yes.
And I think that is, again, maybe it's part of number 3, maybe it's part of your 3rd topic here or your 5th topic here. But I think that is important enough to kind of be a...
Yeah, what is the subsurface like? What surface processes alter what you see on the surface versus what the bulk properties are like?
How well can you read the book? How well can you tell the book by the cover?
Yeah, and you know, those are areas of active research. Let's see, we've talked about identifying and characterizing and search strategies. Now, characterize the surface, identifying strategy, position, and geotechnical properties. And then in this page, we're getting into the the flow down from science into technology into operations. And one of the things I think is important is that we reach out to the commercial folks that want to do resource utilization and try to understand their goals and objectives to the greatest extent possible, because of course there's also commercial advantage and proprietarial information here that one has to navigate. One of the people in our group said that the resource utilization is actually quite important from a technological and exploration perspective, and that this can capture the public's imagination more than pure science, which I'm not sure I believe that. I think pure science captures my imagination, but anyway, I think it's an important point to remember that this is part of the exciting future of our society. Also, I think a real problem that exists is technology maturization. To be able to take resource utilization technology and make it useful for missions. And a lot of the technology that I've seen is kind of stuck in the valley of death between TRL 3 and 4 and TRL 6. And it's hard to make that leap. And this is a program that I think that's a role for NASA in the future, is working through these maturization processes and getting the technology available for missions. Because I've talked to program managers about resource utilization technologies in lunar and asteroid missions, and the basic attitude is that, well, none of it's ready for my program. I think there's a fervent hope that it won't be ready until they retire, so they don't have to deal with it. So, more comments?
Dan, just to sort of highlight some of the things we're thinking about and we're doing in concert with you, right? You see that with Hermes.
Yeah.
Right? So utilizing some of the things that, International Space Station, some of the capabilities that you start leveraging and thinking, pointing to the community, getting NASA also to think about that in a long-term program.
Yeah, Paul Abel, NASA Johnson Space Center, to summarize the point is that there's resources in NASA, particularly International Space Station as a test bed for regolith processes and understanding how to interact with these bodies in microgravity. So we will have iterations of this document available online. I welcome anyone to join our group and interact and put your 2 cents in. And before the next meeting, we should have certainly a draft to be criticized and shot at.
Thank you, Dan. We are now almost 20 minutes behind, and so I'm going to